In this example, I have a raw data set of 15 values for a hypothesis test for a mean when sigma is unknown. So this is an example of a t-test, and I'm going to show you how to get the standardized test statistic and p-value from the TI-84. And this is an upper-tailed test or a right-tailed test. I have the problem written out and a list of the raw scores here. In a nutshell, the null statement was mu is equal to 3.39, and the alternative was that mu was greater than 3.39, and the alternative was the claim in this example. I've already inputted all 15 values into the calculator. I'm sorry, 16. My apologies, there's 16 values in the data set. The degrees of freedom for the critical value is 15. But to use the p-value method, a typical t-table is very limited. So it's strongly suggested you use technology like the TI-84 to find the corresponding p-value. So I already inputted these 16 values into a list. I want to press my stat key, arrow over to tests, and option 2 is the single sample t-test. In this example, I don't have the summary statistics, even though I could find that very easily using the one variable statistics function. Instead, I have the data. So I want to left arrow over to data, press enter, and you need to change the null value. This is from a previous hypothesis test. The claimed value is 3.39, and I need to indicate what list my values are stored in. Now I did put them in list 1 and it defaults to that, so I'm good here. I need to change my direction of alternative to match the problem. This is a right-tailed test. So I'm going to change that to not equals to greater than, and then calculate. Now my standardized test statistic is 1.734, and the corresponding p-value is 0.0517. In my previous video, I found the standardized test statistic by hand, and there was a little bit of rounding with the sample mean and sample standard deviation needed for the formula. By hand, I got 1.735. Using the calculator's t-test function, this standardized test statistic is very close. The p-value is 0.0517. My level of significance was 0.05 for this problem, and the decision is to fail to reject the null. Now, if the level of significance was 0.10, then the decision would be to reject the null. So it is possible to fail to reject at one level of significance and reject at another. And that happens when your standardized test statistic is reasonably close to your critical value.